there's a mountain so big, your brain refuses to see it as a mountain. Stand at its base, and the ground doesn't rise. It just curves away from you. For hundreds of miles. No slope, no peak in the distance, just a horizon that quietly bends around something too large for your eyes to register as a shape at all. You could walk toward it for days and still not be sure you'd started climbing. That's not an exaggeration. That's just what a mountain looks like when it stops behaving like a mountain. This is Olympus Mons. 13 miles tall, nearly 3 times the height of Everest. Its base alone is roughly the size of Arizona. Not the height of Arizona, the footprint. An entire state, swallowed by the base of one volcano. So how does something get this big? On Earth, it can't. Tectonic plates drift. A volcano gets carried away from its heat source before it can grow too large. Hawaii proves it. Islands forming in a line, one volcano after another, each one drifting away from the hot spot that built it. Cooling, dying, while a new one rises behind it. Mars never got that mercy, or that curse, depending on how you look at it. Mars has no moving plates. The ground never moved. So for hundreds of millions of years, the same spot kept erupting. Layer, over layer, over layer. In almost total silence, nothing ever carried it away from the heat beneath it. It just kept building on top of itself, longer than most mountain ranges on Earth have even existed. Picture its outline dropped over a map of your own country. Its footprint could cover an area larger than most nations on Earth. Scientists call it a shield volcano. A low, broad giant, built from thin, runny lava, not violent eruptions. That clinical label completely undersells what's actually there. Shield volcano sounds gentle, almost boring. But scale changes everything. Enough gentle eruptions, repeated often enough, for long enough, without interruption, and gentle becomes monumental. The summit caldera alone is wide enough to hold dozens of cities the size of Manhattan. Its outer cliffs fall away for nearly 4 miles, almost straight down into shadow. Stand at the edge of that cliff, and you're not looking down a slope. You're looking into a drop that would take a falling object over a minute to reach the bottom. For most of the last 50 years, planetary scientists assumed Olympus Mons was extinct, a fossil, left over from a planet that went geologically cold billions of years ago. That was the safe assumption. Mars has almost no magnetic field. Its atmosphere is thin. Everything about it says, finished. A relic world, done changing. Then, something changed. By counting impact, craters on its lava flows, a standard technique for dating planetary surfaces. Researchers found flows that appear to be only a few million years old. On a geological timescale, that's recent. A few million years. On a world that formed over 4.5 billion years ago, is barely a heartbeat ago. It's the difference between a house that's been empty for a century and one where the lights were on last week. It doesn't mean Olympus Mons is erupting now. It doesn't mean it will anytime soon. There's no evidence of that. What it does mean is that the volcano's story may not be finished. A world with almost no wind, no rain, and no plate motion can preserve an unbelievably long pause between eruptions, long enough to look permanently dead without actually being so. Think about what erases a volcano's history on Earth. Rain washes it, wind sands it down, plants take root in it, earthquakes shake it. None of that happens on Mars the same way. So a lava flow that cooled a few million years ago can look almost as fresh as one that cooled yesterday. And one that's actually a billion years old can sit right next to it, barely different to the eye. That's why this discovery matters. Not because it proves anything is imminent, but because it proves silence isn't the same thing as death. A mountain nearly 3 times the height of Everest built itself in silence, one lava flow at a time, on a planet we've watched for half a century, and we almost missed the possibility that its story might still be open. Somewhere under that 13 miles of solid rock, there may still be heat. Slow, patient, waiting, on a time scale that makes human history look like a single afternoon. The solar system doesn't shout, it waits for someone to look closely enough to notice.